Okay, so what we're going to do is we're going to use this b squared minus 4ac and find the value of the discriminant. Now, you're looking at this example over here. You cannot see an a, b, and a c value because it's not in the form of ax squared plus bx plus c equals 0. So you have to put it into that form. So you can either move all the terms with numbers to the left or move them all to the right and have it set equal to 0. I, for whatever reason, like to have my a be positive, so I tend to move it to whatever side this 3x squared is on. It does not matter, but whichever way you want to move it. So if we did that, if we moved everything to the left side, that means we'd have 3x squared minus 8x plus 8 equals 0. And now that we have that, we can identify what is the a value, what is the b value, and what is the c value. That's your first step whenever you're using quadratic formula. What is our a value going to be here? 3. What's our b value going to be? Negative 8. What's our c value going to be? 8. Now, I cannot stress to you enough that when you write in b squared minus 4ac, you're going to have your parentheses around just the b. You're going to want parentheses around just the a and around just the c. Many people will do this wrong and they fail to put the parentheses and then they get the wrong discriminant and their whole answer from there is wrong because your discriminant is one of the first parts that you do. Okay, so your b value was negative 8, your a value was 3, and your c value was 8. So I'm just plugging in those values. Give me a 1 through 5, I'm totally with you. Down to a 1, I have no idea what you're doing, where these letters or numbers are coming from. Okay, cool. All right, so then all you're going to do is PEMDAS to simplify it. At this point, you could also use your calculator. You could go to your calculator right here. The only reason why I'm going to show you how not to use your calculator is because sometimes people do better without a calculator because they fail to put parentheses and their calculator then tells them the wrong answer because you typed it in wrong. So negative 8 squared is 64 minus 4 times 3 times 8, or you can type in negative 4 times 3 times 8, it doesn't matter. So 4 times 3 is going to be 12, and then 12 times 8 is 96, so we're going to have 64 minus 96. And then from there, you could type that in the calculator or do it by hand, it doesn't matter. But I believe it's negative 32. Okay. I will also show you, by typing it in to my calculator, that if I were to type in negative 8 squared minus 4 times 3 times 8, it does not come up with negative 32. Instead, it comes up with negative 160 because I didn't put parentheses around negative 8. Do you see that? So instead, when you type it in, you have to be very careful that your b value is put in parentheses and then you square it. Minus 4 times the a value is 3 times the 8. Yes, it will give you negative 32, but you just have to be careful on how you're typing it in. Does that make sense? Okay, you see the difference there? Okay, so that's the value of our discriminant. Now, based on that, describe the number and the type of roots. Okay, so use the table from above. Okay, oh, you can't even see what I'm writing. Okay, so we're going to use the table there. So it's a negative number. It's not positive. It's not 0. It's negative. So what kind of roots are we going to have for our answer here? 2 complex roots or solution. Two complex roots. So that's all I'm going to do is I'm going to use that table to describe my roots. So far, so good? And when you go to solve using quadratic formula, usually these steps are written out. That's like you're going to have part A, B, C, and D if you're asked to solve using quadratic formula. Now, if I give you a quadratic equation and said solve using any method, you could choose to graph, you could choose to factor, or you could choose to use quadratic formula. And then I wouldn't necessarily walk you through the steps because you get to choose your method. Does that make sense? All right. Really, in all of them, though, you have to set it equal to 0, so that part's the same. All right, I'm going to go ahead and turn this. It says to find the exact solutions next, okay? So how are you going to do that? Now you're going to use the actual quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay? But remember that your discriminant was negative 32. And the discriminant was the value of b squared minus 4ac, which was underneath that radical. Right? So what I'm actually going to be doing here is x equals negative b plus or minus the square root of the discriminant that I already found. Yes. So when I go to write this in, I'm going to fill in everything that I know. X equals negative, what is your b value? Oh, let's rewrite it up here. We ended up with 3x squared minus 8x plus 8 equals 0. So we had an a value of 3, a b value of negative 8, and a c value of positive 8. Now, I typically wouldn't break up one problem to 2 different pages, so we wouldn't have to rewrite our work there. But because of notes, it just went on the front and back because I spaced them out a little bit more. So the opposite of b, plus or minus the square root of, that'll be the discriminant, over twice a. So negative, what was the b value? Negative 8. Plus or minus, what was the discriminant that we found? Negative 32. So that's going to go underneath here. There's no point in plugging in b squared minus 4ac again since we already did that. But that's why it's so important that your discriminant is correct when you first do it, because it comes into play. Your whole answer will be wrong if your discriminant is wrong. Divided by 2 times, what was the a value? 3. So from there, now we're just going to work at simplifying this. Okay? So x equals 8, right? Negative of a negative is 8, plus or minus the square root of negative 32 over 2 times 3 is 6 on the bottom. Okay? Now, this is why it's important that you know how to simplify complex numbers, because this square root of negative 32 right here, this we have to simplify. So I'm going to kind of take it over here. I say this is like my little scrap paper area, because I don't want to have to rewrite that in the problem 5 times if it takes 5 steps to simplify that. So the square root of negative 32. How do I simplify this? What's my very first step? Take out the what? The first step is to take out the negative. When you take out a negative from inside that square root sign, what's it become? An I. So it becomes I square roots of 32. Now when you simplify the square root of 32, you're going to use the same ways that you did it back in geometry. Okay? So you guys did this in geometry, and I believe you did it in Algebra 1, 2, and we did it in here back in 5.4. It was like a pre-5.4 assignment that I had you guys do. So what's a perfect square that goes into 32? What's a perfect square that goes into 32? So we got 1, 4, 9, 16, 25, 36, and then that's too high. So what's the largest of those numbers that go into 32? 16. So the way that I'm going to write this is I stays out front, but it's going to be 16 times what? So square root of 16 times the square root of 2 is the same thing as the square root of 32. Okay? Well, now I picked the square root of 16 because I can take the square root of it. What is the square root of 16? So what I have here is I times 4 times the square root of 2. That's not how I write my final answer, though. I write it with if this was x4, I would instead write it 4x. The same way works with I, so I'm going to write it 4I square roots of 2. And that wraps up my scrap paper. But see, I did this in 5 steps. I didn't have to rewrite this whole problem 5 different times. Yes?
What happens if you get like an odd number square root thing?
What do you mean an odd number square root thing?
I supposed to like simplify that. It doesn't go into
Like if I had 10 where there's not a perfect square that goes into 10, then it would just be I square roots of 10 and that'd be it.
Okay.
You simplify it as far as you can. This one you can simplify a little bit more because there is a perfect square that goes into it. But if not, you still have to simplify that negative sign by pulling that I out. Does that make sense?
Yep.
Okay. All right, so now what I can do is I can replace this square root of negative 32 with this simplified version of it, which was the 4I square roots of 2. So I'm going to rewrite this again. X equals 8 plus or minus 4I square roots of 2 all over 6. So far, so good? Okay, now my last step, what I'm going to do is I have to write this in the form of A plus BI. So I'm going to write 8 over 6 plus or minus the 4 over 6 I square roots of 2. And you'll see why we do this in a second. So X equals, you're just breaking it apart. Really what this is 2 different terms, and both those terms are being divided by 6. So all I'm going to do is I'm going to write both terms being divided by 6. So I have 8 over 6 plus or minus 4 over 6I square roots of 2. Okay, I put the 6 with the 4. Really, you could write 4 times I over 6 or 4I times the square root of 2 over 6. The reason I put it, though, with the 4 is because that's the only thing that it matches. So if 4 over 6 reduces, we'll be able to reduce it. I over 6 is not going to reduce. I couldn't even try to reduce the square root of 2 over 6 because one's in a radical and one's not, which is why I put it with the 4. Is that okay? All right, so then my last step, what I'm going to do is I'm going to take any fraction that I see and reduce if possible. 8 over 6, can it reduce? 4 over 3, so 4/3, plus or minus 4 over 6. Does it reduce? 2/3 I square roots of 2. That is our final answer for an exact solution. And it's in the form of A plus BI, where your I term comes second and your real number is first. So far, so good? Okay, our last one is to find the approximate solutions. So what we're going to do here is type it into a calculator. Now, wait a minute. If I had 2 plus, and I'm just writing this down. You don't have to write this down. Can I combine those two terms? Can this be like 5 or 5i or something? No, it's no different than if this I was an x. These are not like terms, correct? So you can't combine them. The same way that up here you have a number and something I. You're not going to be able to combine these two terms. So your approximate solutions is going to be something plus or minus something I. I can already see that because I have a real part and I have an imaginary part for my two terms. So far, so good? So then in your calculator, 4/3, I just type it in, and the decimal there is 1.333, repeating. Okay? I believe on your homework, well, we can take a little peek. I think for the approximate solutions, it says round to the nearest thousand. Thousandth would be 3 numbers behind the decimal, so we'll do that in our notes. So here, 4/3 is 1.333 plus or minus. The next part, you're going to type in everything other than the I. So you have 2 divided by 3 times the square root of 2. You're going to leave I out of it. Does that make sense? To figure out that value in front of I is 0.94. The 8 would round the 2 to a 3, so 943. I. So far, so good. That would be your approximate solution. Your approximate is when you have to round. So we write those with a squiggly equal sign here, because we are approximate. Those are not exact. This is an exact solution. So far, so good. Okay, I have a couple more that I want to show you and walk you through, because sometimes people struggle from this step here. Like, they can plug it into the formula. That part's not bad, but it's the simplifying where they get thrown off. So I have 2 set up that they're already in the formula. We just have to simplify them. Does that make sense? Are we okay with how I would have gotten 2 square roots of 5 there, the simplifying on scrap paper, or do you want me to go back one more step so I can show you the scrap paper part 2? I can go back the one step, yep. So this one would have started out as 3 plus or minus the square root of 20 over 4. So we'll pretend that that's what it was. And then what we did was we took the square root of 20, here's our scrap paper, and we said, okay, the square root of 20, we're going to have to simplify that. There's not a negative to pull out, so we don't have to worry about pulling out an I here. So what would be a perfect square that goes into 20? 2 is not a perfect square. 4 is a perfect square. Is it the largest perfect square? Well, after 4 comes 9. Does 9 go into it? No. Does 16 go into it? No. 25 is too big, so 4 would be the largest perfect square. So we break that up into the square root of 4 times the square root of what? 4 times 5 gets you to 20. So far, so good? Okay, now what is the square root of 4? What's the value of that? 2. We can take the square root, so we write 2 square roots of 5. That's how they came up with 2 square roots of 5 and replaced that square root of 20. Is that okay? Now that we went back that one step? Okay. All right, so then from there, what we did was we broke it apart into writing A plus BI, technically. But this one, even though it didn't have an I, you still have to write it that way. So you're going to have 3 over 4 plus or minus. What would this next term be? How would I write that? 2 over 4 square roots of 5. Very good. The reason why we still do this is because, look, your 2 over your 4 will be able to reduce. What's 2 over 4 reduced to? 1/2. So we have 3/4 plus or minus 1/2 square roots of 5. Okay. Now in this case, your exact solution, that is your exact solution. So I'm going to write x equals 3/4 plus or minus 1/2 square root of 5. How many solutions do I have? 2. I have 2. The plus or minus are the 2 different solutions. That's how I have to write it exact. But when I write it approximate, because there's not an I in this, are these like terms? There's no I in this. Are these like terms? Yes. So when I find my approximate, I can combine my like terms. So I'm going to have x is approximately or x is approximately. I'm going to write my 2 answers separate. Yes?
So you know that there's 2 solutions only when there's the plus and the minus sign together. So
There's always a plus and minus sign together because that's part of the formula. X equals negative b plus or minus the square root. So that plus or minus is always there.
So there's always two solutions when you're doing the exact solution?
This is what it shows unless that becomes a 0.
Okay.
So if the square root is 0, that's when you guys can't see what I'm looking at. That's the only way you'll have one solution because the square root of 0 is not plus or minus. Plus or minusing 0 doesn't change it. They're the exact same problem. That's why it's only if it's 0. Okay, so then what we're going to do is we're going to actually type this whole thing into our calculator with a plus sign, and then we'll type the whole thing with a minus sign. So for the first one, we have 3 divided by 4 plus 1 divided by 2 times the square root of 5. So far, so good. When I hit enter, that approximate solution is 1.868. Or if you hit second enter on your calculator, the same problem comes up, and then all you have to do is change the plus sign to a minus sign, and you'll have, or x is approximately negative 0.368. Okay. You want to make sure you know how to type those into your calculator because typically people will get the exact solution and not the right approximate solution. That's very important because that's half your points right there. Okay, you'll get a point for the exact solution. Well, actually, you'll get 2 points for it. And then you'll get 2 points for your approximate solution. So if you miss half of them, there's half 50%.
Around 3/4,
You don't need parentheses on this fraction. Nope, because PEMDAS tells you that you have to do multiplication and division before you do the addition and subtraction anyways. Does that make sense? All right, let's try this one. Are you okay that I don't move back and do the scrap paper this time? Because it'd be the same way this one was. It would just be finding the perfect square would end up being 36. Okay, so for this one, your exact solution, when we go to write this, we'd have x equals 7/14, right? Plus or minus what value? 6/14, and then what? Square roots of 17. So far, so good? Okay. Can either of those fractions be reduced? Seven over 14 is 1/2. Okay, so x equals 1/2 plus or minus. What about the 6/14? 3/7. 3/7 square roots of 17. Anything else that we can do? I don't think so either. So that ends up being our exact solution. X equals 1/2 plus or minus 3/7 square roots of 17. I want you to try to type this into your calculator and see if you can come up with the approximate solutions. How many should you have? 2 approximate solutions. All right, so yes, you should get 2.267 or negative 1.267. I have 2 more quick problems to show you. These are the ones that I always assume. It's not on the notes because I assume that it would be easy enough based on if you can do the harder ones and the easier ones should just be easier. But a lot of people then make mistakes on the easy ones. So I want to quickly show you. So just if you put these on a piece of scrap paper or somewhere, if you can fit them on your notes, that's fine. Or if you want to put them somewhere on your assignment or even on something that's from 5.7, since we skipped over 5.7. So if you want to put them right here on the 5.7 notes, that would work too. Since there's a big blank page on 5.7 stuff. Okay, so let's look at this real quick. If I had 4 plus or minus the square root of 0 over 10, how would I go about simplifying that? What's the square root of 0? So when I write my next step, I'm going to write 4 plus or minus 0 over 10. What is 4 plus or minus 0? 4. It doesn't matter if you add or subtract, you're still going to be left with 4. Agree? Okay, so we have 4 over 10. Are we done? Simplify. What is 4 over 10? 2/5. So x equals 2/5. That would be a scenario when you only have one solution because you were taking the square root of 0. Do you see the difference? Okay, so in that case, you'll get down to this. Now, if that was your exact solution, when you go to find your approximate solution, again, just write it in the decimal form. Technically, your approximate is also exact, but we would just write it 0.4. Does that make sense? So technically, your approximate, just always think of that as the decimal version. Your exact is always going to be your fractions. Okay, the next one is also just as quick. What's the square root of 16? 4. So in this case, when we do this, you end up with a number there. -3 plus or minus 4 over 8. You can write it and break it up into your two fractions. Okay? You could write it -3/8 plus or minus 4 over 8. However, you have to do the plus and minus anyways in order to get your exact solutions. Your exact solutions here are not going to have a plus and minus sign in them because they're like terms, you can combine them. So what I like to do is at this point, break it up into your two scenarios. What's -3 plus 4? 1 over 8, or what's -3 minus 4? -7 over 8. Those are your exact solutions. If you can add or subtract them because they are like terms, you have to move on and do that. So we have 1/8 or -7/8 are your exact. So x equals or x equals. Your approximate there then would be x is approximately, okay, go to your calculator, type in 1 divided by 8. We'd have, okay, well, I guess it is exact. X equals 0.125, or x equals -7 divided by 8 is -0.875. So here are your two approximates, but your exact are written separately because you can find the rational root for them. Okay, so when you're looking at that chart, if it's a perfect square, your answer should be two fractions. Two real rational roots. Rational means a fraction. Okay, so it means your two answers are two different fractions. The non-perfect square is two real irrational roots. That's when you'd have a plus or minus sometimes of a square root. Do you see the difference? Okay, so you guys have the rest of the time, so you have 10 minutes before we leave for lunch, to work on the two assignments. Like I said, they are broken up into real solutions and imaginary solutions, because usually we do it over 2 days, but 2 days is equal to 1 day this year. So